for your new needs around your database cluster. This is something about myself. I'm the Trista Pan and the SphereEx co-founder and CTO. Because I spend a lot of time in open source, especially in Apache Software Foundation. So I'm the Apache member and sometimes will help other Apache incubator projects to build their open source community or their database project, etc. Apart from that, now I'm the Apache incubator mentor to mentoring two incubator projects and one top level project. So sometimes I will post some articles about open source, about the open source commercial, and also about distributed database system, about the database management system, and cloud on my LinkedIn or Twitter, such channels. So if you have any questions about such area or about my today's topic, just contact me on my channel. Right, let's get started with today's topic. First, I want to give a brief introduction about database, because if you want to solve that topic and how to this question, we need first to know that how to achieve that goal by upgrade your architecture of your existing database system. So from this diagram, you see here a traditional database. They will have two layers. First one is the computing layer. The next one is a storage layer. So that means our database can help us to accommodate the data and do the requests and answer your questions. That means computing. So your database provides the computing power and the storage power for your application for an user. And for a lot of the monolithic database or traditional databases like PostgreSQL, MySQL, or Oracle SQL Server, they merge their computing layer and storage layer together. That means you can deploy your one single PostgreSQL instance or database in one machine. But if you want to, but you gradually found that you want to make this database become the distributed system, you need to consider another issues or solutions to help you to solve the current issues from your database. So that's the basic, the factors or elements of your database system. That could become the solution for our distributed or sharding architecture if we can deploy our computing layer and the storage layer independently, make it become a distributed storage nodes or computing node. That means your new database solution can help you accommodate more data, enormous data, and can answer your questions so efficiently because all of the requests will be executed in different locations. They can leverage the different machines to help you answer the one question, right? So that's the magic of your distributed database system. That's why people will consider this new architecture to help them to manage more data, right? But we also need to consider that your database may be located in the cloud or on the premise. That means you can have a lot of choice for your database infrastructure. Yeah, so that's all the basic elements for us to pick up one of the fitting database for your scenarios. The next one, let us discuss about the new requirements from our new era. Because of the big data phenomenon, that means the big data, you need to deal with the different flavors of your data types. You need to consider that and how to get the fast answers from the enormous data store, right? So that's your requirements, your new needs about your databases. And also how to make their database have the high availability, make it become the auto skill in or skill out to help you solve the issues based on your current scenarios and requests, right? And especially when you have a lot of database cluster, you also need to consider how to automatically manage them. That's the new requirements from the big data. The next part, like I said before, it's about the cloud, the infrastructure. You don't want your application or your service are located in one cloud vendor or one cloud platform. So you will consider the multi-cloud or cloud native or database as a service, right? So big data plus cloud infrastructure will make your now database infrastructure have to do some changes for your new area or new requirements from your application. That's the background. That's why we want to answer this question: how to upgrade or how to transfer your existing PostgreSQL database cluster, become a distributed one, become the sharding one, and make it have the security such features. Yeah, so let us discuss about the solution. Currently, your MySQL or Postgres or Oracle works well for the before and for current, but you also need to consider how, for example, after 5 years or 3 years, how about my database? How about my database can support the more TPS or QPS from our application and help me to manage the database clusters and help manage the tremendous data, right? How to answer the question efficiently. So today's solution, I will bring you the following benefits. Meanwhile, help you solve the issue about the current at this time point, you need to finish all the requirements from such a phenomenon. So the benefits from today's solution that it can help you leverage the existing database cluster and upgrade your existing database cluster, become a distributed one at the low cost, and also help you consider how to move your database into your cloud, right? Because I believe your application now or in the future will all of them move into the cloud platform, especially on Kubernetes, right? And how to become the multi-cloud or no locking into one database vendor. So that's all the benefits from today's solution. To reach that goal, I need first to introduce this open source project because we need to use this project to help us to upgrade your existing database cluster. So what's the ShardingSphere? ShardingSphere, it's an ecosystem to transfer any database into a distributed database system and enhance it with the sharding or skill out and encryption feature and more. So from this slogan that we found, it looks possible that help us to upgrade our database system because see here it can transfer your database into a distributed one. So okay, it looks great. And next I want to answer another question that could I trust this project? Because everyone want to use a mature project, and we hope that we can get the support or helps from this open source community as fast as we can, right? So from the statistic, I guess the statistics or the data on GitHub can answer you that question. Okay, it's trustable. Why? Because this project has received like 70,000 stars and also have 6,000 forks. This community have the more than 400 contributors in this community. Also has been released nearly 15 times, right? Plus, you can see here it presents our end users a lot of documents or manuals to help us to quickly set up this project or know more about this project by ourselves, right? So looks this community and this project have a lot of users and contributors. That means we're not the first bunch of the user to use this project. Thanks to this mature community or thanks the end users or contributors that make this project to fix all of the common issues from this industry or from the market, right? So that can help us fix the first issue, the trust issue. The next one, let's consider the solution. So why do these projects can help us to solve that issue? Because like I said before, our traditional database actually is made up of two parts. First one is computing part, second one is storage part. So at this solution, actually if we want to upgrade existing database, that means all of our existing database instance, no matter it's the Postgres or MySQL or Oracle, it could become the local storage nodes, right? They will become the storage local storage nodes and take charge of the storage work and also about local computing work. And ShardingSphere, it will become the global computing nodes, right? So here, your global computing nodes plus your local storage nodes, multiple local storage nodes will group this distributed database system, right? So ShardingSphere here, it will works as the distributed the database server. If your local storage layer are the PostgreSQL instance, then the ShardingSphere will pretend it as the distributed PostgreSQL server, right? So you don't need to change the approach way to your previous PostgreSQL instance if you use the Postgres Java driver or use the CLI or other PostgreSQL database management platform. That's okay. You don't need to change any the connection way or connection method to the ShardingSphere, right, or to your previous PostgreSQL, because ShardingSphere will works as it is a PostgreSQL distributed server, right? So that will friendly for end users or for your applications to do such upgrading process, right? So you just need to change your connection from here to there, right, to this one. So the ShardingSphere will receive people's requests and do the PostgreSQL or render it as the internal objects, do some SQL optimization and to calculate which PostgreSQL have your data and to send that the subqueries to different local storages, that means your PostgreSQL instance, and merge the local result become the final one, return result to your application, right? So you can see here we can regard the ShardingSphere plus your existing PostgreSQL instance as the one single distributed PostgreSQL database. So that's our solution, that's our architecture. And this page will show us, because I want to say here, the ShardingSphere present us two clients for us to choose. The first one is ShardingSphere Proxy that I introduced before. ShardingSphere Proxy, it plus your PostgreSQL will become the distributed database. So you need to deploy ShardingSphere Proxy independently in one machine or server, right? And the ShardingSphere JDBC, it's a lightweight JDBC driver for your Java application. So if your application is developed with Java, then you can just import this Java into your application, and you use ShardingSphere JDBC to visit your PostgreSQL instance. So it can help you manage this database cluster. And no matter it's a ShardingSphere JDBC or ShardingSphere proxy, both of them share the same feature. It can help our end users to shard your databases to prevent the distribute transactions, or help you do the rewrite splitting to improve the throughput of your database system, and also do the data encryption or auto data encryption or decryption. Yeah, so the clients share the same features, but the proxy will have the actual features about the database management. But the ShardingSphere JDBC has the high performance than the ShardingSphere proxy, because here you can just directly visit your database from your application to your databases. But here you need actual visiting, you need actual TPC visiting or connection here, right? The twice, here is the only one time, right? So when the ShardingSphere proxy or JDBC receive users' requests, that's what will happen internally here, because all of the requests will first reach to ShardingSphere, so it will understand what the meaning of your request. It will can also do some rewriting or changes about your request, your SQL statement, right? So that's why it can support you with such wonderful features: SQL audit, sharding, data sharding, high availability, traffic governance, etc. But today, we just want to use two of the features to help you upgrade your existing database, become the distributed one. So from the architecture, for example, if your architecture is here, your PostgreSQL or MySQL, SQL, located in the different cloud, and your application just visit your database cluster, and now you don't need totally to change this architecture, your existing architecture. You just need to create the your ShardingSphere cluster and import ShardingSphere between your application and your databases, and no need to change anything about your databases and your application. And then you can finish all of the progress or upgrading process, right? So that can easily help us to finish the upgrading process. And another benefit for us is that it can help you to automatically skew out or skew in your distributed databases flexibly. Why? Because if today you found that you need more like your local storage nodes, that means your database instance to help you store more data, then you don't need to do anything around your database, your ShardingSphere cluster, just to pull up more like the database instance. You can finish all the stuff. But another case, if you found that you don't need more databases to help you to manage your data, but you found that you need more computing power or your global computing nodes to help you improve the high availability of this system, you can just skew out your ShardingSphere cluster. That means your computing layer, right? So all of the skew in, skew out for your storage nodes here, for your computing nodes, it's independently and flexibly and automatically, right? That's just amazing. So next one, I need to introduce what's the distributed SQL, because if we deploy this distributed system, import ShardingSphere into your existing architecture, then we need to leverage, we want to use the enhanced features here. That means your data encryption or your data sharding, right? So how to use such features? Before, if we want to create a table, we can use the SQL to tell, or SQL statement to tell our PostgreSQL that I want to create a new table. Please help me do that. But now, if we want to create a sharding table, it's not a single table. It's a logic table. It's a sharding table made up of different subtables of different your actual tables, right? So here we need a distributed SQL. Distributed SQL, it's a specific the SQL language or the SQL-like language to help our user to use such features. So here an example, if you want to create a table, you can just create a table, the T order, right, for your PostgreSQL. But now you use the distribute SQL. Here you can see here the create a sharding table for your T table order, right? So that means currently you use this distributed SQL to help our sharding table, right? It's made of a lot of the subtables or actual tables, right? So here you can see this case. There are a lot of the sharding key or sharding algorithm or for which table, which column, right? You can also use the author, the job, or the any other the SQL like language, the distributed SQL help you to leverage such features in this new database system, right? So that's the functions of the distributed SQL. The next one, I gave a lot of the ideas about this solution. We want to do this demo show and to tell you the solution, right? The by manual. So I will give the demo show about including the following items. First one, how to do the deployment on Kubernetes, how to test the high availability of this new database system, a distributed system, and how to create this one, right? How to answer the question about our topic. The first one, ShardingSphere provides ShardingSphere charts on the Helm repo. So, or administrators or end users just use the Helm, the comments on the CLI, the client, and you can use some the Helm comments to pull this charts and deploy this distributed system on the Kubernetes. So you can see here this case, by use the ShardingSphere charts, it can help you to create this computing layer all about the ShardingSphere factors or elements of this distributed system, about the global governance, about the ShardingSphere operators on the Kubernetes to help you to guarantee the availability and the automatically skew in, skew out feature around your ShardingSphere proxy, right? So here we have the computing nodes, ShardingSphere proxy. We have two computing nodes here and two operators to help us manage the ShardingSphere proxy, and one ShardingSphere government to help manage the global metadata here. And today I just use another PostgreSQL charts to help us to create the PostgreSQL instance on Kubernetes. If you already have your PostgreSQL instance, you can just ignore this step, right? You can just use ShardingSphere charts to create this computing there, and you already have the story layer, right? So that's about deployment. If you want to learn more, you can just visit in the ShardingSphere on cloud repo on GitHub, or you can visit our official website, and it will bring you to this one. The next part, let us test the availability of the ShardingSphere. It also means the automatically scaling feature about the ShardingSphere proxy. Here we can just modify the spec of this configuration, or you can see here we make this automatic scaling enabled, and the minimal instance is from the 1 to 2. So if at the beginning I deploy 1 to 3 ShardingSphere proxy in this ShardingSphere cluster, but when I release with this new configuration or spec, then you will find the 3.1 will skew in into 2 ShardingSphere proxy instance in this cluster, right? That's the high visibility over the scaling features to show you here. Also, the ShardingSphere operator, if you found that here you cite the minimal instance is 2. If the ShardingSphere operator found that there is only 1 instance ShardingSphere proxy in this database, the Kubernetes cluster, it will set up a new one to guarantee this number, 2 instances in this Kubernetes cluster. So that can help us to guarantee the high availability of our computing layer, right? The next part, we need to use the distributed SQL to log in the ShardingSphere proxy, this new distributed system, to create this logical DB and logical table here. So we use the ShardingSphere SQL to tell the ShardingSphere proxy to visit or be aware of your storage nodes, and we use the distributed SQL to create this logic table. This logic table, it's mapping to 1, 2, 3, 4 subtables existing 2 different PostgreSQL instances, right? So that means we shard these T users into 2 PostgreSQL instances. And we can also see here, if there is a telephone number column of this table, we need to encrypt all the data in this column, become the cipher text and stored in our PostgreSQL instance, right? So here we can use the distributed SQL to tell ShardingSphere automatically encrypt the privacy data and store them into your PostgreSQL instance. When user want to get the telephone number, ShardingSphere will automatically decrypt the cipher text, become the plain text, and send the plain text to our end user. So that's a function of ShardingSphere proxy. So here we use the distributed SQL that here create a sharding table for the T user, right? We split this T user into 4 ones, right? And we also create an encrypt rule for T user. Here we use AES algorithm to encrypt our data about this column, telephone number, right? So we create a table, we insert data for texting, and we select the SQL, execute the select statement here. You will find the telephone, that's the plain text. But if you log in your PostgreSQL instance, you will find all the data here. It's automatically encrypted here, right? So that's the work of the ShardingSphere. That's the feature of ShardingSphere can help a user do. Alright, so that's about today's talk. And if you also have any questions about today's topic, you can just contact me on my LinkedIn or on my Twitter. I will do my best to answer your question. And plus, we also publish, we have a new book to introduce more about ShardingSphere, and now we have a gift for our users. If you want to have this copy of this book, you can just tag Apache ShardingSphere on Twitter, and our ShardingSphere Twitter guys will send you a copy as a giveaway. Right, so that's all about today's topic. I hope you enjoyed this topic and have a good night or good day. See you. Bye.